Okay, so one question we have for sure on the test will be something like A or B here. Just can you combine? Can you work this out? So we're just so you know what we're looking for, just so there's not confusion. And actually, these instructions suck. They're terrible because the way I would write it, I would say express this complex number situation or express this actually hold on. How would I say this? What you want to do is perform the complex number division with your final answer in standard form or A plus BI form. So I want the final answer in A plus BI form. What that means, I got to multiply top and bottom by 1 plus 2i. That's how you get kickstarted. If you do that, it's not so hard, right? Because I know you guys can foil it. And we like this problem because it combines all the stuff that we've done with complex number arithmetic in this unit. It's going to have foiling, and it's going to have addition and subtraction of complex numbers, right? And then simplification afterwards. If I FOIL the bottom, you should get 1 minus 2i plus 2i minus 4i squared. This is done with an intention, right? Because we want the i's to cancel in the middle. Why did I choose 1 plus 2i? Because I want the i's to cancel in the middle for the bottom of the fraction. So what happens when I FOIL it correctly? What happens to negative 2i and positive 2i? They cancel, right? And what's I squared, guys? We know this now. What's I squared? Negative 1. So it's 1 minus negative 4, which of course will be 5 on the bottom. Now let's go up top. 2 times 1, you have 2, negative 5i, positive 4i, and negative 10i squared. Awesome. Now things won't cancel. That's okay. What's negative 5i and 4i? Negative I. Negative 10i squared is positive 10 because it's negative of negative 10, so it's 12. So we're okay with what I have so far? Does that make sense? How I've combined stuff? But don't leave your answer like this because the instruction is going to say, I want A plus BI form. So I need the A and BI separated. So it's got to be 12/5 plus 1/5 I. That's how the final answer has to look. Okay, so that's how 141 is done. B works the same way. I don't need to work out B now because now you know what's going on. I'll show you the answers really quickly so you see them for both. So for 141, yeah, 12/5 minus 1/5 I. Boom. Oh, actually, I made a mistake. Sorry, it's 1/5. Negative 1/5. My apologies. And then the other one's negative 3/13 plus 11/13 I. I do applaud the answer key for writing it the right way. I don't applaud the instructions because instructions are incredibly vague. And as someone who's taught pre-calculus and AP Calculus AB, I aim to be very precise in my language. Sometimes my colleagues don't do that. So I'm going to make sure the language is very precise so that you guys know exactly what is needed. Okay. So that's expectation for 141. And there will be a question like that on the test for sure. Now for 143, do you expect something like part B or part A, either one could work. Do you expect a question like that on the test as well? So what I would do for this problem, and we're not going to give you the formulas for sum of cubes or difference. Now, if you do have a formula accommodation sheet, great. You could put the formula for sum of cubes or difference cubes. And that was this stuff here, if you remember from the notes from yesterday, no, 2 days ago, on Monday. So if you do have an accommodation, you can get this if you want to put it on. If you don't have an accommodation, we're not going to provide it. But here's the thing, you don't need it. We don't want you to become formula dependent, right? We want you to become formula independent because that's when you get better at math. When you're formula dependent, math sucks. If you're on the formula, you don't know what to do. But you guys can do this. What makes this 0? What would make a 0, guys? This should be pretty quick. No one, thank you. So what's the factor? X plus 1, right? And we already talked about this. You do the Polydoku thing. The Polydoku thing, once you know the process, it's not that hard, right? X cubed, 1, X, 1, X squared, X squared. There's no X squared in the process, negative X squared, negative X, negative X. There's no X, so positive X, 1, boom, got it. X plus 1, X squared minus X plus 1. And then find the other zeros, use quad form. I trust you guys to do quad form just fine. There's no need to review that again. You guys should be fine with quad form. Use quad form. I think you get 2 imaginary answers, if I'm not mistaken. And likewise with B, if you did B, you get the same thing. So, yeah. That was 143. There you go. There are the answers. Not so hard. Now, just so you know, on the test, we're not going to ask 145. That's not on the test. This is more just review for the final. This will be more of a final exam review question for 145. But this won't be on the test next week. Square both sides, work it out. You should get 1/2 is your answer. And I think one of the answers is extraneous if you were to work it out. So, okay. 147. We are going to ask this on a test. Okay, so this is good. So let's talk about 147. Yeah, go ahead.
Do you have a calculator on this test?
Is we calc? Actually, good question. Hold on. I don't think so, actually.
Yeah.
For function, yes, for sure. Maybe scientific will be okay also, I think. But I don't graph. I don't think we're allowed because there's yeah, let me double check. I'll know for sure by tomorrow.
Okay.
Yeah. But for this one here, he knows that there are two complex zeros, -2 plus minus 5 by one real zero. Great. What could his original function have been? We've talked about this before. We had this on the previous unit. Remember, if x equals -1, then x plus 1 equals 0. We know this, right? We know this. This was the other one that was a little tricky. Remember I said this, like try to go in reverse order. Then you know this has to be true, right? Plus or minus 5i. Then this has to be true. That's -25, by the way. And then this has to be true. And then you just FOIL these together to get the polynomial. So that's what you do. So that's how I would go about that problem. That's a more efficient way for doing it. Just work backwards. Like, okay, you know x equals -2 plus minus 5i. Then try to get 0 on the other side and see what the factor would have been. And then just FOIL afterwards, and you should be good. For 147, here's the final answer. It's just that. And I do feel good. I see a 29 there. I feel good about it. That looks good to me. Yeah, there should be a 33x. Yeah. 4x and 29x. Yeah, that's good. Should be 5x squared, 4x squared, 1x squared. Yep. Feel good about it. Looks good to me. Bless you. Okay, for 149, that's more the same as the first problem. More the same stuff. So just kind of just go through the motions. Like you're gonna multiply top and bottom of a by 5 plus 3i to get i's to cancel on the bottom. For b, you're gonna multiply top and bottom by 1 plus I. Okay. Okay, why do we ask this 3 times? That's so lame. I'm sorry, guys, I did it 3 times. That is ridiculous. Okay. 156, same thing. I'll show you the answers for them. Here's 149. Here's 156. Okay, I still need to do a screenshot of all these answers. I'll get around to it. And then logs. No logs on the test, but factoring for sure, because factoring was an issue on the last test. So factoring for sure will be on the this upcoming test. But you should know your logs. It's gonna be on the final. So let me show you the answers for that. Any questions on that you guys want to ask about that you're curious if you figure out how to do logs? No? Okay. Just so we got 4 full days for final exam review. So yeah, we'll have 4 class meetings. Is that good or bad?
No, it's fine.
You want more? Or less?
Wait, what did you say?
There'll be 4 days for a final exam review before
Final exam review.
the final exam. We'll have 4 full days. It's like who's on first, who's on second. No, just kidding. It's like Abbott Costello. No. Not necessarily. But let me hold on. Look at the monster's question. I'll get back to this. Yes, go ahead. Yeah, great question. Okay, all good questions. So let me tackle all this right now. So just timeline again, as I like to do, just always to check in. So today we're going to do a new topic on rational functions. We'll do another new topic tomorrow. After tomorrow, no more new material for the rest of the year. I'll have the chapter review ready by tomorrow. And I'll have more details about the test by tomorrow. So you can use the weekend and start studying. Monday, I'll try to do, okay, I know you guys want Jeopardy. I'll try to get Jeopardy back to a little more extra credit. I'll try.
Yes.
I'll try. It is Mother's Day on Sunday. Be nice to your moms, but anyway, once you have what, sorry? Got it. Okay, but you got to take care of your mom. But anyway, we'll have review on Monday, test on Wednesday, and then on that Friday I'll have the final exam review. I'll try to have it even ready on that 15th as well, but definitely the 17th we're going to talk about it. The 20th, 22nd, sorry, the 16th. I don't see you guys on the 17th. Guys, quiet please. Thank you. And then we have the 20th, 22nd, 23rd. And again, as I promised, I'll be available on the 14th in the evening before our next test. I'll be available on the 27th in the evening before our final exam. We have lots of office hours, X and Y periods as well. So there's lots of opportunities to come and get the help you need. Remember, this next test will count as a retake. So the previous test didn't go well, but if you do well in the review portion, I will update your grade. So if you do well in the next test, that's great. You get a good grade, and we update the previous grade too. So it's a double impact, right? That's in a good way. So, but remember, we're not going to quite have a retake for this next test. I don't know how that will look exactly. So I'm on to go.
Okay, what stuff in the last minute?
Great question. Factoring for sure. I think on quadratic formula. What else? I think like if you're given the solutions, like working backwards, like this kind of question we just did right now. Number 147 for sure. That will be on there as well. And there's one more question type I can't remember. It's not coming right now, but it'll come back to me. Actually, let me pull up the whole test. I think it'll come back to me. Hold on. So unit 5 tests. Oh, like this one. Yeah, definitely a question like that will be on test. Yes, like that one.
And take a picture.
Like those two. I'll tell you guys tomorrow. Don't worry. Like these two for sure. And it wasn't on the last test, but something like 147 also. So expect that. And then of course all the new stuff we're doing. So all right. Okay, I think I'm done going over the homework. Let's now move on to the new stuff. So the new stuff is right here. Called section 8.9. It says 4.2.1. Now, just so you know, this can be a really complicated topic. We're going to go light with this because we're almost done with the school year. Plus, you're going to see this again in pre-calculus. But we do need to talk about how to graph rational functions, like how that graph will look. It does tie very closely to polynomial division as well. So we'll have that discussion. But we're going to kind of keep it light because it can get pretty intense. Homework's already built into this packet, just so you know. It's not going to be CPM stuff because CPM actually kind of fails us in this regard. We kind of had to make our own stuff here. So on page 3 and page 4 is the homework problems. And I'll work it out while you guys are doing it, just so you have the answer key ready to go, because these are not CPM problems, or not on the CPM textbook. So let's get going with the notes here. So let's talk about rational functions. So this is, are you feeling rational? I mean, obviously, this is a play on words, right? But yeah, what is a rational function? A rational function is this. That's called a rational function. Why is it called that? It's called that because it's a ratio. So if I get a little highlighter here, all it really means, a rational function is a ratio of two expressions. That's it. That's all it ever is. What are my expressions here? 1 and x. That's pretty simple, because 1 is just a number and x is just one variable. But we can get other things too. Like, for example, we will be working on this kind of stuff. Like, you can see something like this here, 2x plus 1 over x squared minus 5x plus 4. That's a pretty complex one. We're not going to make you guys graph this stuff by hand for this unit or even for this class, because we're near the end of the year and it's a little too much. You're going to see this again in pre-calculus. But that's a rational function, right? Because you have a ratio of two expressions. Let me actually take that back. It's a ratio of two polynomial expressions. Two polynomial expressions. One polynomial, another polynomial. Even 1 and x counts polynomials. Even though 1 is one number, x is one variable, we still consider it to be a polynomial. Remember, what's the definition of a polynomial? You guys, some of you guys botched this on the last test. What's the definition of a polynomial function? The exponents have to be what? No, whole numbers. Whole numbers. Exponents have to have whole numbers, guys. So as long as your expressions have whole numbers, you're cool. The ratio of that is a rational function. That's why it ties closely to polynomial functions. Okay. Now, here, let's graph this, right? Without a calculator, sketch a graph. Think of the transformation 1 over x. Okay, great. Let's do it. So here's what we're going to do. Here's what I want you guys to do. What makes x plus 2 equal to 0? What makes x plus 2 equal to 0? What x value? What do you guys think? -2, great. Also, we see 3 here, right? Y equals 3 if 1 over x plus 2 goes away. Okay, so let's simmer on this a little bit. I don't want to rush too much because this is the part where guys can stop. Let's focus, please. Thanks. This is the part that kind of gives you a deeper understanding of what's happening here. Okay, so if x is -2, that's a problem. Why is that a problem if x is -2? You have 1 over what? It's not a problem. You can't do that. That's weird, right? Something's weird. Also, I said that y, g of x is y, right? Function notation, f of x, g of x, f y, it's all the same thing, right? If this fraction goes away, if this fraction's gone, what are we stuck with? 3. But here's the problem. Can that fraction go away? Can I make that fraction vanish when there's a 1 in the numerator? How do you make a fraction vanish? What has to be true about the numerator?
One has to be bottom two.
Well, no, if you have 1 at the bottom, you have 1 over 1, which is 1. What has to be true about for the entire thing to be gone? What has to be true about the top?
Make it 0.
0, exactly. If the top is 0, what's 0 divided by anything? 0, right? So we know that. So these things can't really happen, right? So here's the reality. The reality is that y can never equal 3. And 1 over and x can never equal 2. That's the reality. Just can't happen because you can't divide by 0. And why? Because 1 over cannot just vanish. Need numerator be 0 and cannot divide by 0. Hence, x cannot equal 2. -2, my bad. My apologies. Let me fix that. Much better. There we go. That's the reality, right? Y can never equal 3 and x can never equal -2. So what does that mean? What that means from a graphical perspective, we're going to do this. And for those who play like I shouldn't talk about this at a school, but for those who play shooting video games, when you play these shooting video games, your aim is to, well, let's play on words. Your aim is to aim at the target, right? You got to aim at the target. How do you aim at the target? Usually you need a crosshair, right? I use this analogy when about 15, 20 years ago when James Bond GoldenEye was very popular on N64. So I go way back in the day with video games. I don't play video games anymore now, but I'm sure I'll get back until my son starts playing them, much to my wife's displeasure. But anyway, so here's the deal. I'm going to do this, guys. So you can have x equals -2, which I call a vertical asymptote. You have y equals 3, which I call a horizontal asymptote. We talked about asymptotes before, right? We talked about them with exponential functions, right? And log functions. Rational functions have asymptotes as well. These are boundaries that we usually don't cross. So think of this as like you're aiming the function at a certain place. It's kind of like, I know it sounds terrible, but like if you're playing these shooting games like Fortnite, I don't know these games. You guys sit that on. Or what's another game you guys play? Like COD, right? Probably or yeah. Or is that am I just too old fashioned now?
No, people
Still do play this game. Okay. Anyway, you're aiming the graph. How do you aim the graph? It depends on these numbers here. In general, we can think of it like this. Y equals A over X minus H plus K. Where H and K are the transformations. So I know I'm being a little long-winded here, but that's what we need to do. H is -2 here. K is 3 here. We move 2 left, 3 up. So that's where we're aiming the graph. Now, I'm going to make a quick table and do the graph. So let's pick numbers close to the asymptotes. What numbers for X should I try that are close to the asymptotes? What are easy numbers I should plug in? Give me an idea. They're close. They're in the neighborhood of the asymptotes for X. For X, by the way. So I have a vertical asymptote at -2, right? What's close to -2? -1 and 0, maybe. And how to the left side? -3 and -4. Yeah, perfect. Good. If you plug in -1, I trust you guys could do the plug-in just fine. Just trust me. You get 4 and 3.5. Here I get 2.5. No, 2 and 2.5, I think. Yeah. You plot the points. Not hard, right? I know you guys can do it. Plot the points with -1, 4, 0, 3.5. So graph looks like this. See how it swings down like that? Or here. Cool. That's how the graph looks. Now let me answer the rest of the questions. And let me get rid of all this junk here. So for part B, state the domain. It's all real numbers except what? What value of X can I not use? We talked about this. -2. The range, that's my domain. My range will be all real except what number? What Y value am I not getting? Y cannot equal what? We just said this. Y can never equal what number? 3. There you go. Yep. And just you see it from the graph. State the intercepts. All right, we'll do it. I don't think it's necessary to find the x-intercepts. The y-intercept's easy. That's 1 over 0 plus 2 plus 3, which is 3.5. The x-intercept, I really don't want to do it, but we'll do it. What the heck? Plug in 0 for y, solve for x. If you do that, you should get -3. If you cross multiply, you should get this. -7/3, which makes sense. It does look like -7/3. So, all right, we did it. That's fine. Asymptotes already did that for you guys. X equals -2. Y equals 3. You gotta write equations, guys, please. And then the end behavior. As X values increase, what do the Y values do? They go towards 3, and they go towards 3 here as well. I think we'll treat this as a fill in the blank now because I was pretty lax about it on the last test. The other class actually more formal about it, but that was my fault because I didn't teach you the formal way of writing it. I'll treat this as a fill in the blank. I'll like actually on the test, I'll say, here's this, and just got to fill in the blank. So as X gets large, right? What's happened to Y? Is it leveling off? Yeah, towards 3. What's happening to Y as X goes towards to the left? Is it leveling off towards 3? Yeah, it's leveling off. Totally 100% it is. As it should be, because you have +3 at the end. Because here's the deal. 1 over X plus 2 up top here. I don't really dissect this like crazy, but I need to. 1 over X plus 2 gets super small. As X approaches positive or negative infinity, right? Gets super small. That's what happens. Yeah, what's up?
for the zero, or zero on the top of the, it's negative, maybe,
0, what do you mean?
what over x is two, how do you make that zero to make?
You can't make it 0. It's impossible. You can't. That's why we have that horizontal asymptotes. That's why we have that boundary, because we can't make. So it's just, but more specifically, it's because as x gets bigger, y is getting closer to 3. Because whenever x plus 2 can, whenever x plus 2 can get really small, when x gets large, like what if x is 1,000,000? You have 1/1,000,000 too, which is like 0.0000, but it's never exactly 0. It gets awfully close to 0, but not exactly. All right. Next up, write a possible. Ooh, I love this question. This is actually one of my favorite questions. This could be a test question. If not, final exam question. Love this question. All right. So the crosshair. I know this sounds terrible. Crosshair, which is really basically your vertical and horizontal azimuths. Where are we aiming this graph? What's the center here? Where is that, guys? -6, comma. Oh, you're right. No, you're right. It's not -6. Where is it? -5.5, you'd say? And y equals what? Perfect. Are those my asymptotes? Done. See how easy that was? I didn't have to. All I had to do was just find the center of those two dash lines. That's all I had to do. Is actually going to have 5.5. You bet. Y equals 2. You bet. Done. Those are my asymptotes. Got them. Yep.
If it was a question, would you give us the dash lines or?
Of course, I have to. Yeah, 100% would. Yeah, 100%. Because I need to avoid the ambiguity. 100% I would. Yeah. Sorry. Go ahead. We're not done yet. Yes, I got the. Sorry, we're not out of the woods yet. Sorry, I got a little too excited. Okay, so generally speaking, this is the formula for a simple rational. Actually, technically speaking, it should be A. That should be an A there. But you know what? Let's not worry about it. We'll just say it's 1 because I didn't give an extra point on the graph. So for now, we'll say it's 1. And so if you think about it, x cannot be -5.5. So it's going to be x plus 5.5. And y cannot be -2. So I put a -2 here. So those represent the h and k values. The center of that crosshair. Because by putting -5.5, I have a problem. Now I'm divided by 0. And y cannot be -2. So this fraction here cannot be 0. So it gets something small, -2, to put -2 right there.
These are always over. Always over these ones.
Sorry, what's what?
Is one always over?
You know, not technically no, because which should be happening. You should be given a point on the graph and you have to test it out and solve for A, like we did for some other problems in the past with polynomial functions. But in this case, they didn't give us an extra point, so they're assuming it's 1. I'll tell you if it's 1. I'll tell you. Yeah, or if it's not, then I'll say you got to solve for A. Yeah. They said possible equation, so yeah, it's possible. All right. Polynomial division. Ooh, this is a good one. I like this one a lot. This is good. All right. This could be a test question too. So this is very simple. 1 over x. You know, we know now we know what's going on with this, right? It's very simple. We actually call this a simple rational function because it is simple. But the one in the example is not simple. But what do? Use division. So here's how I'm going to do it. Hold on a sec. Wait 1 sec. Why am I drawing a blank here? Hold on, I'm like totally drawing a blank. How to approach this problem. I don't want to do the long division because I don't want, if I could help it. Actually, crap. Let's just do long division. Sorry, I don't know if the Polydoka thing works for this one. It just seems weird to me. That's okay. Let's just do long division. Okay. How many times does x go to 3x? 3, right? So you get 3x plus 6. If I subtract it, what do I get? 1. So if your remainder is 1, you get this. So what does that become? That becomes the same thing as this here. So what we've done is we've transformed this into a simple rational function. We have 3x plus 7 or x plus 2. You can actually rewrite it like that. So now I can graph this pretty easily, right? So where are the asymptotes? That's easy. X equals -2, y equals 3, right? Where are the intercepts? That's easy. The y-intercept is going to be 7/2. That's easy. And then the x-intercept, I think we just did this one already. Yeah, we already know. We did this one already, guys. Yeah, we just did this one. Yeah, I don't know. I didn't realize that. Yeah, duh, guys, we just did this graph. Sorry, I don't have to repeat myself. But what do you notice? It's the same as the first example. Same as example number 1. Okay, I'll definitely do this faster the other class. So just because it looks a little different, it's still the same darn thing. It's the same thing. Just written a little differently, but same thing. So what we can do now is we take that same approach for number 4. And 5 is kind of crazy. But let's work out 4 really quickly. So use polynomial division to rewrite it. Okay, great. So you can just do this. X minus 3, 2x minus 5. What do you multiply to x to get to 2x? What do you guys multiply x to get to 2x, guys? 2. Hopefully you guys are okay with that. Subtract, you get 1. So that's what that becomes. It becomes that. Where the asymptotes, that's easy. X equals 3, y equals 2. If I graph it, graph this guy. Okay, the y-intercept is 5/3, which is right here. I don't like that contrast. Let's go dark green. And the x-intercept, if I solve that, is over here. So graph looks like this. If I plug in 4, for example, I should get 3. So they basically have to go against the asymptotes. That's how the graph goes. So I have the graph done, asymptotes done, intercepts done, polynomial division done. Lastly, we'll do the end behavior. Alex, go ahead. You need a negative out front. Yeah, you guys will explore all this stuff in pre-calculus. We're just kind of scratching the surface of this stuff here. Describe the end behavior. So again, I'll actually have a fill in the blank situation for you guys, but I'll basically say this: like as x approaches positive infinity, what does y do? As x approaches negative infinity, what does y do? In both cases, they both go towards 2. That's how you describe the end behavior. Like that. So we're not going to ask a question exactly like this on a test, but we'll probably say, here's an equation, give me the asymptotes, right? Or maybe describe the end behavior. What would you expect for that? Or maybe do polynomial division and break it down this way. So, but you know, this is kind of the beginnings of rational functions. So, but yeah, you could totally rewrite it by doing division. Because that's what it is. It's division. That's all it ever is. And it's a transformation afterwards of 1 over x. So that's the key takeaway, guys. Rational functions are simply a division between 2 polynomial expressions, and we can then think of it as 1 over x with some transformations. That's the takeaway from today's lesson, really. That's it. That's all it is. Rational function is simply a division of between 2 polynomial expressions, and we think of it as a 1 over x with some transformations. That's really what it is. So in this case here, and actually, that's not true for all rational functions. I should take that back. But what we're doing in this class, that is true. Okay, last thing we'll do, and this is and they're all done. You guys can work on the homework. These are called complex fractions because they do look complex. It's not so hard once you get the hang of it. So it's basically a fraction within a fraction. That's what's happening there. It's a fraction within a fraction. Okay. So if you think about it, what's the LCD here for part A? What's the least common denominator among all these fractions? How many fractions do you see in part A? How many little, you see 3 little fractions. What's the LCD for all those? The least common denominator. Not more than just x. Well, what if you want to add, what if you want to combine these two? What would you have to multiply the top and bottom of the first fraction by to make them to match up? 3x, right? So what's the LCD, guys? 3x squared. You guys are a little rusty. It's okay. Because we have done this least common denominator. Or like the least common multiple. So here's what you're going to do. I'm going to rewrite the problem. You look at what each factor is involved. Well, kind of in a way. I mean, for example, like you have x and 3x squared, right? So you know to multiply this by 3x, get these to match up, right? So guess what your denominator is now? 3x squared.
What about that thing on the bottom?
There's x squared also, so we're gonna still use the same thing. So here's what you do, guys. You do this. You multiply this by 3x squared. And you multiply this by 3x squared. So you multiply that by 3x squared and that by 3x squared. If you do that, you should get 12x squared over x minus 15x squared over 3x squared. 24x squared over x squared plus 18x squared. You get 12x minus 5 over 24 plus 18x squared. So you got to find the LCD. Any way of doing it, things cancel out very nicely. And all's good. So it's just multiplication, then you just clean it up afterwards.
What do you do from there?
You're done. That's it.
You use factors?
If you can, but if we can't, we don't worry about it.
Wait, so what if we get a problem with the
Then you just leave it like that. You're done.
Uh.
I asking the factor this part. We'll circle in black.
Mm-hmm.
You can if you want, but I mean, I could take a 2, or sorry, 3 from the bottom. Sorry, 6 from the bottom, but it's not gonna cancel with anything. Let's try one more time and we're done. 1 over x plus 8 over x plus 1 over y squared. Okay. Now, just so you know, this is not on the test. This is not on the test. Probably won't be on the final either. But it's something we should talk about. That's why we're doing it. Yeah, this particular concept, it won't be on the test. So I'll give you guys more details about test tomorrow. But my LCD here is x, y squared, right? Because you have x and a y squared. So you get x, y squared over x plus 8xy squared all over x squared y squared plus x. Clean it up. Y squared plus 8xy squared over x squared y squared. And you can factor out if you want, but nothing cancels. So yeah, that's the best we can do. So that's just yet another way of writing it. So it's called complex fraction. We just use this technique to, some people have more complicated ways, like they combine the numerators and denominators and divide afterwards. I just like find the LCD for everything, multiplying by that. It's a shorter process. But some people will actually combine these two. Some people will do this: 1 over x plus 8 over 1, multiply by x and x, and get some fraction 8x over x plus 1 over x. And then they do the same thing over here, and then they divide those two fractions afterwards. That's just more steps. I don't like that. I prefer to do it this way. Find the LCD for everything, both top and bottom. Okay, we're all done. Homework's right here. I'm gonna work through it and try to post the answer key. We still have another 10 minutes or so, and that's it. We're all done. And our last lesson will be tomorrow for the year. So